So welcome back. We are going to discuss with borax, which is the compound of boron under the group 13 category. So let's write here. So erase the board. Okay, borax is mainly the chemical formula for sodium tetraborate decahydrate. Okay, we will discuss it one after the another. Okay, so follow me. Okay, so let's write here, give the heading borax. Okay, in borax there are also many names in which by which the borax is called. Okay, in India or in the world you can use the names of, you can find borax is commonly called as tinkled, CO commonly, okay, commonly called. It is also called tinkle, TINCAL, okay, or you can call it as suhaga, okay. So it is also known as tinkle or it is also known as suhaga. Okay, this was the first point. Let's now learn the formula, chemical formula. Just a minute. Okay, so formula is sodium tetraborate decahydrate. Okay, so this is the chemical formula for your borax. Okay, so chemical name, write it down, sodium tetraborate decahydrate. Deca means 10, hydrate. Okay, so the chemical name is sodium tetraborate decahydrate. After this we will come to the method of preparation of borax. Okay, so coming here, I am writing method of preparation as MOP. The first and foremost, it is from colemanite. Okay, so what is colemanite or what is the process? Let's discuss it. It is from Ca2 B6O11. This is colemanite. Okay, so this is colemanite. Now colemanite, when you treat it with Na2SO4, this is your, I'm sorry, this is Na2CO3, I'm sorry, sodium carbonate. Okay, this is sodium carbonate. Now when you do it, what you get here is Na2, this thing you get here, B4O7 plus NaBO2, and this Ca and this CO3 will form CaCO3. This is your borax. Okay, now again, when this NaBO2, when you again treat it with CO2, you get Na2B4O7, which is also borax. Okay, so this is the method of preparation from colemanites. You have to remember this compound. This is called colemanite. So what did I do? This is Ca2B6O11. I treat it with sodium carbonate, which is Na2CO3. I get sodium tetraborate decahydrate, which is my borax, Na2B4O7. Then I also got NaBO2. I also got CaCO3. Now on treating NaBO2 with CO2, I get again the borax, which is the same thing. So this is a efficient method of preparation of borax. Okay, so copy this. Next we will come to the chemical preparation, or I am sorry, chemical properties of borax. Okay, copy it. Okay, so let's clear it out. Give the heading chemical properties. Now in this we will study a very few things, which is borax is acidic or basic, the composition of borax, okay, hydrolysis of borax, and application of heat on borax. Okay, so give the heading. Let's change the color of the pen. Okay, so give the heading chemical properties, or else write properties straightly. Properties. Okay, so we will discuss the properties of borax. Okay, so right here the first point you write borax solution is alkaline in nature, which means it is basic in nature. Okay, now why? Because see, it is Na2B4O7, right? Now when you perform hydrolysis, okay, you get NaOH plus H2CO3. Now if you know NaOH is a strong base and this is carbonic acid, okay, this is a weak acid. So borax is a composition of strong base plus weak acid. Okay, you can write a point here. Borax can act as a acid buffer. Okay, buffer is the thing which you have studied in chemical equilibrium of class 11. Okay, coming to the next property, we will learn now application of heat. Now we will learn what happens when we heat borax. Okay, so let's write the entire borax. Na2B4O7 dot 10H2O. Okay, so when you heat it, okay, when you heat it, what do you get is this 10 hydrogen will move out. On side 10 water will move out. So let's write heat over here. So you get Na2B4O7. Now when you again heat it, what you get is NaBO2 plus you get you get NaBO2 plus you will again get a bead, means you will get B2O3, and this entire thing is called glassy bead. Okay, now this entire glassy bead thing we will study in the last part of this series of the crash course, where I will discuss about the borax bead test. Okay, that is a method for identification of various compounds. So this is also called glassy bead, or you can write it as sodium metaborate. This is sodium metaborate, and this is a boric anhydride. You can call it as glassy bead or a mixture of sodium metaborate or boric anhydride. So you copy this. After this we will learn about the structure of borax. Okay, let's clear it out. Now we will study the structure of borax. So, structure of borax. Now, from the structure of borax, if you know the structure, you can easily attempt a few questions which asks you about the hybridization of boron in borax, also the number of BOB linkages and like that. I will discuss everything. So, let us start with the structure of borax. Structure. Now, borax have the chemical formula Na2B4O7.10H2O, right? Now, it exists, it does not exist in this way. When you draw the structure, you have to write it as Na2B4OH whole this is Na2B4O5, I am sorry, this is Na2B4O5 OH whole 4, okay, and then entirely it is 8H2. See, it is Na2B4O5 OH whole 4 and then 8H2O. Okay. Now, if you do not remember this is not an issue, then you have to mechanically remember the structure. The structure is quite easy. First, we will draw the number of borons. Okay, let us erase this. This is complicating the entire thing. Let us erase this. We are going to draw the structure of borax. Okay, B, I draw 4 borax. I'm sorry, 4 boron. Okay. Now, this is BOB linkages. Let's erase this and write it over here. Na2B4O7.10H2. Right. So, this is the BOB linkages. How many B? 1, 2, 3, 4. How many oxygen? 1, 2, 3, 4. Okay. 5, 6, 7, here 8. Right. Now, see, you have to put hydrogen over here. Okay. So, let us remove this hydrogen, and similarly here also hydrogen. I hope this part is visible. Okay. Now, again oxygen will come up from here to here. So, how many? 1, 2, 3, 4, boron 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I missed to count something, right? Let us count again. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Clear? Just check it out. Okay. Now, if you notice carefully, a negative charge is being developed over here, right? Now, you have to replace it by sodium, okay, and here also with sodium, Na plus. Now, with entire this thing, I will have water bonded like this, 8H2. So, mechanically, if you remember the previous formula, which is Na2B4O5OH whole 4 8H2O, then it wouldn't have been so difficult for you to remember. Okay. Let us draw this again. So, this time I will draw it directly. Okay. Let us see how much you remember. Okay. So what I did, I drew the boron first, B1, B2, B3, B4. Okay, make the VOB linkages 1, 2, here also 1, here also 1. Okay, and now with every boron 1 OH, here also 1 OH, and here also 1 OH. Okay, a negative charge is supposed to be developed over here. So what I do is, this negative I attach one sodium here, with this negative I attach one sodium here. Okay, now with the entire this thing, 8 H2. So this is the borax. Okay, note it down. Okay, now from here question may come that hybridization of borax, boron, HYBD of boron. Okay, you can find from here by calculation the hybridization of boron is sp2 and sp3. sp3. Okay, number of VOB linkages. How many VOB linkages? Let us count. I am sorry, I missed out this one. Okay, count the number of VOB linkages: 1, 2, 3, 4, and 5. It's 5. Now number of lone pairs, count. See, here lone pair will be 34. If you count properly, it will come 34. Okay, because oxygen here is 2, 2, 2, 2. Similarly, if you do the entire thing, we will get lone pair, number of lone pair, it is coming equal to 34. Okay, note it down. So this was all about borax. Next we have the boric acid. Okay, or you can also call it as the orthoboric acid. So copy it down, then I will clear the board. Okay, let's clear the board. Give the heading boric acid H3BO3 or orthoboric acid. Okay, this is number 2. Orthoboric acid formula H3BO3. Okay, method of preparation: first and foremost from borax, the compound which we studied just now. What is the formula for borax? Sodium tetraborate decahydrate. Decahydrate will not come here. Okay, so when you treat it with aqueous HCl, aqueous HCl, from here you will get NaCl plus C. NaCl is moving out. What is left is H3BO3. H3BO3. Okay. Now, if you treat it with H2SO4, okay. Now, this has to be also aqueous. You get Na2SO4 plus H3BO3. This one is more important because this one is not in the NCERT book. Okay, so copy it down. This is the method of preparation of boric acid or orthoboric acid from borax. Okay, let's remove it, or else write an important point here as note: properties Note: it is monobasic. Okay, this is first point. It is weak acid. It is non-protic. It is Lewis acid. Okay, so these are the important properties of your orthoboric acid. Copy it down. Next we come to the other properties. So let's erase this. Heating effect. Okay, similarly heating effect. All right. Here the heading heating effect. Heating effect. Okay. It was H3BO3. Now H3BO3, when you heat it at 100 degrees centigrade, you get metaboric acid. Okay, so what is the formula? HBO2. This is metaboric acid. Now when you again heat it to 150 degrees centigrade, you get tetraboric acid. This is H2B4O7, like this. This is tetraboric acid. Okay, you have to remember the name. Now when you again very strongly heat it, again we are heating it. Okay, so let's write here strong heat. You get a compound called B2O3. This is called boron sesquio oxide. Okay, copy it down. So this was all about your boric acid. Okay, so next I come to the structure of boric acid, which is the last thing left in this category. So I'd write here, it is a very simple structure. H3BO3. So for doing this, let us first draw boron. Okay, so this is boron. Okay, how many oxygen? 1 2 3 3. Finished. Okay, now let's attach one hydrogen with it. Right, now see, this hydrogen has the ability, or this oxygen has the ability to attract other molecules of H3BO3. So let us put some dot here, because other molecules may have the ability to join here. Okay, so the structure becomes like this. Okay, structure is some sort of like this. Okay, note it down. Now here if they ask you about the hybridization of boron, it is sp2. Okay, this is intermolecular H bonding. Copy it down. So with this we come to the end of the orthoboric acid. Next we will come with the last portion, which is the diboric acid, and we will at the end we will also discuss some chemical properties or some important points about the boron family. So copy it down. In the next video we will discuss them. Thank you.